Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. This is our fourth video on factorising quadratic expressions. Let's just start with the puzzles of sums and products I've asked you before. Pause the video and answer the following 5 questions. Okay, hopefully you got the following answers. Now, there was something special in this case. In order to multiply to 0, one of the numbers has to be 0. One or both of the numbers are 0. 0 times anything is 0. So we know to get a product here of 0, one of these numbers is 0, and then to get the appropriate sum, the other number must be, in this case 1, in this case -1, 2, 9 and -12. Because, let's say here, 0 multiplied by 9 is obviously 0, and 9 add 0, 9 is the only number that when you add it to 0 gets you to 9. So that's a little puzzle I wanted you to think about and it's going to be useful in this skill. The other one is just to think about the type of expressions we're going to factorise. So far in our quadratic session, we've factorised things like this. And we were looking for two numbers that multiplied to positive 20 and added to positive 9. What were they? Well, they were positive 4 and positive 5, so this factorised to x add 4, x add 5. And we're used to that type of thing. This is the type of expression we're going to try and factorise in this particular video, where there's no number term on the end. Now it's funny, we've actually done this before, and we've done it in a really simple way. We did it in manipulating algebraic expressions when we were factorising simple expressions. So we've actually done that, and I wonder if you remember how we did that? Well, we said, looking at this here, we've got x squared here, and there's an x here. The common factor is x. And in my bracket is going to be 1x, because x times x gives me x squared, and positive 9, because x times positive 9 is positive 9x. So we've already done that, and we're good at this, so presumably you're good at it. The only thing I wanted to use this skill for is to show you that the way we've been doing it, looking for numbers that have a product of something and sum to something else, also works here. Why? Well, there is no number term, so we can just think of that as adding 0. And what we're looking therefore for two numbers that multiply to 0 and add to 9. And we know the only two numbers that do that are 0 and 9, because 0 times 9 is 0 and 0 add 9 is 9. So our brackets would be x add 0, x add 9. And mathematicians, x add 0 is just x. So a mathematician would just write this as x add 9, which is the same as we used to factorise. So the only point of this skill is just to point out to you that in these cases you kind of know how to factorise them already. The trick or the method we've used in all cases also works here. So it's just comfort for you to know that if you know this one method and you like it, it will also work in these cases. Right, let's try some questions here, maybe shown both ways. Factorise the following. Two ways to think of it. Either you add a 0 on here and you ask yourself the question, what two numbers multiply to 0 and add to 3? Well, they're going to be 0 and 3. So in my bracket I'm going to have x add 0, x add 3, which I would just simplify. In fact, I wouldn't write x add 0 with a bracket around it, I'd just write x add 3. Similarly here, we're thinking of two numbers that multiply to 0 and add to -3, so it's going to be x add 0, x subtract 3, which would just tidy up to x subtract 3. And the last case, two numbers that multiply to 0 and add to 7, it's going to be x add 0, x add 7, which we'd simplify to x add 7. Now, to be honest with you, I think it's a bit long-winded doing it this way. I'm only showing it to you to give you comfort that the methods I'm showing you work in all cases. When I see this without the 0, I don't bother putting it in, and I just think of this as a special case where this has got a common factor of x, this has x, so I just write it as x plus 3. Here I just see there's a common factor of x there and x there, so I just say x subtract 3. Similarly here I just write x add 7 as quick as a flash. But just to show you both methods work, whichever one you like the best. Pause the video and have a go at these ones. Well, hopefully you remembered our last skill. Before you launch into the ones where there's more x squareds, there's more than one x squared, just look at that number and that number and see if there's a common factor in 2 and 14. There is. There's a common factor of 2. So we can have a factor of 2 on the outside. Then I'd look to the algebra and I'd say, right, is there a common factor in x squared and x? There is indeed a simple x. And therefore, what I'd say is, what goes here to multiply by 2x to get 2x squared? Simple x. What must go here? Positive 7. And similarly here, I'd look at the numbers first. I'd look at, is there a common factor of 3 and 15? Indeed there is. I can take out a factor of 3. Then I'd look at x squared and x and say, well, there's a common factor of x there. What goes here? So if I multiply it by 3x, I get 3x squared. Must be an x. What goes here? So I multiply it by 3x to get negative 15x. Must be a negative 5. And as you will hopefully know, if you've worked through manipulating expressions, these actually will be super familiar to you, and there's nothing new learnt here. But I just wanted to point out to you that that's a type of quadratic expression which I didn't mention to you before, and it's a type you may be asked to factorise. Last two questions. Pause, make sure you have a go. Okay, if we're asked to factorise that, we're going to first look at the numbers. The highest common factor of 8 and 4 is 4. So I'm going to factorise out, or factor out a 4. Then I'm going to look at x and x squared and decide, there's a factor of x in both of those. Now I open up my brackets and I say 4x times what gives me 8x, must be 2. 4x times what gives me negative 4x squared, just must be a negative x. Times it out before you go on to check you got it right. 4x times 2, 8x. 4x times negative x, negative 4x squared, done. This one here, well, firstly look at the numbers. The common factor or highest common factor of 6 and 9 is going to be 3, so take out a factor of 3. The highest common factor of x and x squared is going to be a single x. Open up your brackets now. What goes here to multiply by 3x to get 6x? Must be 2. What goes here to multiply by 3x to get negative 9x squared? Must be negative 3x. Times it out before you go on. 3x times 2, 6x. 3x times negative 3x, negative 9x squared. Done. And that's it for this particular skill. So I was showing you a way of factorising something you kind of already knew, but just pointing out to you that these are actually quadratic expressions and you may see them coming up in the topic of quadratics. Thanks loads for watching.